So this is the fifth lecture of work energy, power and collision. In this lecture, we'll discuss from question number 141 to question number 146. So they're basically simple in nature. Just follow through the questions and tell me if you understand, or if you have any doubt, just write it in the comment section. Okay. See, in this question out here, this mass is kept on top of a slab. Okay. And this slab is being pulled by force F. The coefficient of friction between the mass and the slab is given as mu. In irodov they use K, but I'll use mu so that it's easier to understand. And this mass is attached by a spring. The spring has a spring constant K. Okay. So as this force is applied, what will happen? This entire system will start to slip. Okay. The question is saying is that this mass does not slip over this block. Okay. That means this slab carries this mass m towards right. So after some time, what will happen? After some time, the slab will move towards right. And as the slab moves towards right, no, after a certain while, what will happen? The horizontal component of spring force is so much that it balances out, or it becomes more than the static friction that is carrying this mass m towards right. Okay, and this mass m will start to slip over this slab. The point at which this mass starts slipping over this slab is when the spring makes angle 30° with the vertical. Okay, that means what? From here till up till here, there was no slipping. That means the friction force that was carrying this mass m towards right, okay, was not sufficient enough to cause slip over this surface. Okay, so when the spring makes angle 30°, what will happen? The block will start slipping over this slab. Okay, the question is asking, find out the work done by friction force. Okay, who is moving this mass m towards right? The friction force is moving this mass m towards right. The friction force applied by the block, applied by the slab on the block, okay, that is moving this mass m towards right. Find out the work done by friction force from this position, or from the initial position till the position that the block starts to slip. Okay, so let's say the block started to slip somewhere around here. Okay, and this is the slab, and out here it started to slip. This angle is given as 30°. That means I have drawn this diagram and this diagram, that is the same thing. Okay, out here the block started to slip. Okay, find out the work done by friction force in taking the block from here up till here, from the frame of reference of someone sitting in the ground. See, from the frame fixed to the plane. That means what? See, work done, okay, kinetic energy, these all terms are dependent upon frame of reference. Okay, for example, okay, suppose I say kinetic energy of a body, is equals to half mv square, where v is the velocity. Now velocity is dependent upon frame of reference, Similarly, work done is nothing but force into displacement, or dot product of force and displacement. Displacement is dependent upon frame of reference, So this term will depend upon frame of reference. Even if you see by block, suppose I kept my observer in this slab, okay, what is the work done by friction force? 0, because up till this position, this slab was not moving with respect to a frame kept on slab, But if I keep my frame, or if I keep my observer on the ground, what will happen? This friction force, or the friction force applied on the block of mass m, is moving this block from this position to this position. Understood? So work done is dependent upon frame of reference, and the question is asking, find out the work done by friction force from moving from this position to this position. So the approach in this question would be work energy theorem, okay, where work done by work energy theorem. Achha, let me write this properly. Okay, where work energy theorem states that change in kinetic energy of the body is equals to work done by all the forces on the body. work done by all the forces on the body. Okay, now what is change in kinetic energy? So what was the initial velocity out here? The initial velocity was 0. What is the final velocity out here? The final velocity is 0. Why is the final velocity 0? Because the plank is slowly shifted. That means acceleration out here is equals to 0, and the velocity with which the shifting is being done is very small or infinitely small or nearly equals to 0. So initial velocity is equals to 0, final velocity is equals to 0. So what is the change in kinetic energy? Change in kinetic energy is final kinetic energy, which is half m into 0 square. So 0 minus 0, which is equals to 0, is equals to work done by all the forces. Now, in order to understand work done by all the forces, you need to first consider what body you are considering. I can either consider this block alone, or can consider a system of this block and the slab. Okay, both approaches will be correct. However, if you take the block or this slab, okay, inside the system, you have to consider this force. Then the work done by friction force would be an internal force. That means work done by friction on this slab will cancel out the work done by friction on this slab. Okay, so in order to avoid all those complications, I just take out, or I apply work energy theorem on this block only. Okay, so work energy theorem I am applying on this small block of mass m. So work done by Asha. First, second thing we need to consider is what are the all the forces acting on this mass m. So FBD of m of m. So if I see properly, okay, this is m. Who is pulling this block? Friction force that is being applied by this slab on the block. Okay, downward is mg force, upward is normal reaction force. Normal reaction force applied by the slab on the block, and in this direction, at the end point, it is making, or this is the friction force. But friction force is equals to k into x. But x is nothing but elongation of the spring. So work done by friction force plus work done by normal reaction force plus work done by gravity force plus work done by spring force. Okay, see out here. Work done by normal reaction force would be 0 because displacement is perpendicular to the force. Similarly, work done by gravity force out here would also be 0 because displacement is perpendicular to the force. So if I look at this equation, 0 is equals to work done by friction force plus work done by spring force. Okay, now work done by spring force, if I look at this equation, work done by spring force is nothing but negative of work done by friction force, or work done by friction force is nothing but negative of work done by spring force. Okay, this is the concept that you are going to use. Now one more thing you might ask, sir, what happens if we use mu into n and find out this displacement? See, that wouldn't work because from out here till out here the block was not slipping, no. Okay, so the maximum value of static friction wouldn't be applied. Okay, and the friction force, although it's being applied, it has lesser value than maximum value of friction force, which you don't know. Understood? So from head to head, the friction force is gradually increasing up till this point where the maximum value of friction force is applied. And out here, when the maximum value of friction force is applied, the body starts slipping. Understood? So we cannot apply mu into n into this length. Okay. So you have to find out the work done by spring force, and work done by friction force is nothing but negative of work done by spring force from this equation. Achha. What is work done by spring force? Work done by spring force is nothing but minus kx square, or minus half kx square, where k is the spring constant and x is the elongation of the spring. Okay, so if we replace this out here, minus half kx square out here, it would be work done by friction force is equals to plus half kx square. Minus and minus will become plus. So work done by friction force would be half kx square, where k is the spring constant and x is the elongation of the spring. Now from previous problem, unlike previous problem, okay, what is the elongation of the spring, or what is the change in length of the spring. Change in length of the spring is nothing but this length minus this length. And similarly, like previous problem, what is this length? L naught sec theta. L naught sec theta or sec 30. Okay, out here this angle is given as 30. Okay, what is this much? L naught tan 30. Okay, so what is change in length of spring? This length minus this length, or L naught sec theta minus L naught. So out here x is equal to nothing but L naught sec theta minus sec theta. If you take L naught common, L naught into sec theta minus 1. Okay, fair and fine. This is the value of x. Problem is, what is the value of k? Okay, I need to find out the value of k out here. I need to find out the value of k out here. Okay, what is the value of k? See, for the value of k, I'll do force analysis out here at the end position. Okay, this is the point, or this is the point when the block starts slipping. Okay, so maximum value of friction force would be applied. And what is the maximum value of static friction force? Mu into n. And what is the angle it makes? 30 degree. It is given in the question. See, maximum angle it makes is with the vertical is 30 degree. If this angle is 30, this angle or this angle would also be 30. It is given in the question. Okay, so if we analyze the vertical component of force, vertical component of force is nothing but kx cos 30, kx cos 30 into, sorry, not into, plus n minus mg is equals to mass into vertical acceleration. What is vertical acceleration out here? 0, because the body is not lifting up or going down, no. So vertical acceleration is 0, so is equals to 0. Okay, or from this equation we get n is equals to, I'm shifting all this term to the right hand side, mg minus kx cos 30. Okay, similarly, if I do the horizontal component of force, this is nothing but the vertical component of force equation. Similarly, if I do horizontal component of force equation, I'll get kx sin 30 minus friction force, or friction force minus kx sin 30 is equals to mass into horizontal acceleration, and the horizontal acceleration is equals to 0 out here. Why? Because the block is moved slowly, okay, or with zero acceleration or infinitely small velocity. Okay, that's why I can do fr minus kx sin 30, and both are same. Means if you just multiply by this, you can take any direction as positive and any direction as negative, as long as this acceleration is equals to 0. These are nothing but numerical, shortcuts. So out here is equals to 0. What I'm trying to say is, in previously I said no, fr friction force minus kx sin 30, but I have written kx sin 30 minus fr. Both will be same, because out here I have done 0, no. So if you multiply this by -1 and multiply 0 by -1, you'll get the same thing. It doesn't matter out here. Okay, conceptually it should be friction force, or this side as positive, this side as a negative. So friction force minus kx sin 30. Okay, so out here, what is the value of friction force? Mu into n. And what is the value of n? Mg minus kx cos 30. So if I rewrite this equation, I'll get something like kx sin 30 minus mu into, what is the value of m? Value of m is mg minus kx cos 30 is equals to 0. So from this one, what I'll try to do is I'll isolate the value of k and x. Okay, so can I multiply mu by both this term? Okay. Now can I take kx common from this term and this term? Now I'll just send this mu mg to the right hand side and divide this entire term by mu mg. I'll send this mu mg to the right hand side. Okay, or out here kx is equals to how much? Mu mg by sin 30 minus mu cos 30. Mu cos 30. Now what I'll do is I'll find out the value of half kx square. Work done by friction force is nothing but half kx square. Okay, I'll use this equation, and this equation. Okay, these three equations I'll use. Where theta out here is nothing but 30. It is given in the question, 30. So using these three equations, I'll find out the work done by friction force. Now these are the three equations I got from last question. So to solve for half kx square. So can I write work done by friction force? I can break down half kx square as half kx into x. What is the value of kx? Mu mg by sin 30 minus mu cos 30, or is equals to half mu mg by sin 30 minus mu cos 30. Okay, and what is the value of x? X is nothing but L naught into sec 30 minus 1 into L naught into sec 30 minus 1. Okay, sin 30 is nothing but 1 by 2, cos 30 is nothing but root 3 by 2, and sec 30, which is the opposite of cos 30, is nothing but 2 by root 3. So if you rewrite this entire equation, I'll get something like this equation. Okay, now I can take out common 2 out from here and cancel with this 2. So this 2, this 2 and this 2 will get cancelled. So I'll get 1 minus mu root 3, or 1 minus mu root 3. Now how can I simplify this? Achha. L naught I can bring it out here. L naught is out here. Okay. 2 by root 3 minus 1. I can take root 3 as denominator and make this entire thing as 2 minus root 3 by root 3. Okay. The value of mu in the question is given as 0.2. 0.2 can be written as 1.5, but I'll go with 0.2. Okay, it's much simpler that way. Or work done by friction force is equals to mass is given as 1 kg. Okay, mu is given as 0.2. G I know to be 10 or 9.81. I'll use 10 out here. Okay, L naught. L naught is given as 40 centimeter or 0.4 meter, because I'm using SI unit. No? Okay, and what are the remaining variables? Mu done, M done, G I know, and L naught also done. There is no other variable, no. So it is nothing but mu 0.2 into M 1 into G. G will be 9.81, but I'll use 10 out here, into L naught 0.4 by 1 minus mu. Mu is nothing but 0.2 into root 3 into 2 minus root 3 by root 3. When you use calculator, it will be around 0.09 joule. Okay. Now in this question, okay, this is a rod. Okay. And top of this rod, there is a ring out here. Okay. This ring, a ring of mass m. The mass of the rod is weightless. That means the mass of the rod is 0. Now this ring is connected by a spring out here. Okay. Or this ring, not with the axis, with the rod, at the end of the rod. This ring is connected with a spring out here. The spring constant is given as K. This ring is allowed to slide, okay, in this direction. So as it goes in this direction, the string stretches and it will be pulled back. Now what this system is being done is, this system is rotated with angular velocity omega, okay, about this axis. So after a while, what will happen? The centrifugal force, okay, will act on this ring. and will pull this ring in forward direction. Okay, and what will happen? The spring force will pull the ring in backward direction. The question is asking what work must be performed to slowly get this system going and reaching to angular velocity omega. That means some torque to rotate this axis with angular velocity omega. Okay, there must be some torque applied, no? Okay, initially the entire rod was static. That means it was not rotating. Now, as soon as I start rotating, okay, after some time it will reach equilibrium, or after some time I'll see the system, okay, and I'm seeing the system when it was rotating with angular velocity omega. Now, to make this system to rotate with angular velocity omega, some torque must be applied. Some torque must be applied on this system. Okay. The question is asking what is the work done by this torque to move this entire setup from zero angular velocity to omega angular velocity. Well, understood the question. Okay. Now let's see this entire system from top or top view. Okay. If I see this entire system from top view, okay, out here is the ring. Okay, the ring of mass m, and here is the spring. Okay, now as this ring was rotated with the angular velocity omega, when this ring was moving with angular velocity omega in this direction. Okay, so what will happen? The spring will get stressed, so the spring force is equals to kx in this direction. If I observe from the frame of reference of the rod, there is a centrifugal force pulling on this ring, no, which is equals to m omega square into distance of this ring from the axis of rotation, but this is the axis of rotation. Okay, m omega square into this distance. Now what is this distance? The question is saying the initial length of the spring was L naught. Okay, that means when the spring was, or when the rod was not rotating, the length of the spring was L naught. And when the rod was rotating, what will be the length of the string? Initial length plus the elongation of the spring. Understood this much? Okay, when the rod was not rotating, when the rod had angular velocity 0, okay, when the rod was static, that means what? The string was in normal position, or the spring was in normal position. The normal length of the spring is given as L naught. So as it is rotating with angular velocity omega, the spring will get stressed, no, because this centrifugal force is pulling this ring in outward direction. So the angular velocity, or the angular velocity as observed from this frame of reference, will cause a centrifugal force. Okay, this centrifugal force is pulling this ring in this direction, and the spring is pulling this ring in opposite direction, and they'll maintain the balance. Okay, so the spring will get stressed by distance x, and the entire length from the axis of rotation is nothing but L naught plus x. So m omega square into L naught plus x, m omega square into L naught plus x. Now if I balance out the equation out here, okay, force balance, m omega square L naught minus x, or centrifugal force, minus kx, spring force, is equals to 0, because from this frame of reference the spring is in, or the ring is in equilibrium. Okay, so out here, can I analyze for x? Of course. So x will have some certain value, or this is equation number 1. Now I need to find out what is the work done by this torque to bring the system from this position to this position. So I'll apply work energy theorem. Work energy theorem on this entire ring plus mass setup. Okay, so what is the initial velocity? The initial velocity was 0 out here. What is the final velocity? See, the final velocity of ring would be half m into v square, where v is nothing but the tangential velocity of the ring. Okay, and what is tangential velocity out here? V is nothing but omega into R. Okay, omega into R is nothing but V out here, where V is equals to omega into L naught plus X. So what is the final kinetic energy? Half mv square, where V is equals to omega into L naught plus X minus initial kinetic energy. Initial kinetic energy of the ring is 0. Okay. Achha. What is the final kinetic energy of this rod? See, if the mass of this rod was given, okay, then the final kinetic energy of the rod would be half into mass of the rod into velocity of center of mass of the rod. But since this rod is light, okay, smooth light, that means the mass of this rod is equals to 0 out here. So do not consider the mass of this rod. So final kinetic energy is equals to 0 for this rod, and initial kinetic energy is already 0 for this rod. Understood? Is equals to work done by all the forces. What is the force acting on this ring? What are all the forces acting on this ring? Okay, there is torque acting on this ring, so work done by torque. Work done by torque. Okay, is gravity force acting on this ring? Of course. But is the ring moving in this vertical plane? No. The displacement of all points in this system will always be perpendicular to the gravity force. Okay, so work done by gravity force is equals to 0 if gravity force exists after all. Okay, plus work done by, now we'll see at the ring out here. Okay, we'll analyze the ring. Okay, from the outside frame of reference, okay, what is the work done by spring force? Work done by spring force. Okay, plus, see, when you're taking work done by torque, no, that means I'm analyzing it from outside frame of reference. And in outside frame of reference, does this centrifugal force exist? No, the centrifugal force is a pseudo force when I change my frame of reference to the rotating frame. Understood? So out here, work done by torque plus work done by gravity, which is equals to 0, plus work done by spring, okay, is equals to half mv square minus 0. Are there any force acting on it? No. Achha, there is one more force, normal reaction force. What is making this rod move in a circle? Normal reaction force, no? So work done by normal reaction force. See, work done by normal reaction force will also be 0. Why? Because this ring, okay, is rotated by a rod, no? So out here normal reaction force would be in the direction of velocity. So it would have some positive work throughout the circle. Okay. So normal reaction force applied by the rod on the ring is positive, but that which has the same magnitude of equal and opposite normal reaction force is also applied on the rod by the ring. So normal reaction force by the ring on the rod would be in this direction, and the rod is also moving in this direction. So normal reaction force on the ring and normal reaction force on the rod would get cancelled. So work done by normal reaction force on the ring and work done by normal reaction force on the rod would get cancelled. So we can easily say that normal reaction force are internal force. Understood? Normal reaction force into displacement of the ring is equals to normal reaction force on the rod into displacement of the rod. Okay, this ring would have positive normal work and this rod would have negative normal work, and both the magnitudes of work are same out here. Understood? So we need to find out work done by torque. Work done by torque is nothing but half mv square minus work done by spring. And what is work done by spring? Initial minus final. What is final? Half or minus half k x square, where x is nothing but half k x square, because spring force is always opposite to the direction of displacement out here. Okay, now if we analyze this equation out here, okay, if I rewrite this equation properly, it would be half mv square, where m is the mass of the ring, is equals to work done by torque, minus half kx square, where work done by spring, or work done by external force torque is equals to half mv square plus half kx square. Okay, this is our equation number 2. And what do we have to find out? We have to find out work done by torque, or what work must be performed by external force out here. So leaves this equation and this equation and find out the value of work done by torque. Out here I made a small mistake. It is not L naught minus x, it should be L naught plus x. Okay, the final length is L naught plus x, so L naught plus x. Now when I use these three equations, I get the value of work done by external torque. Okay, so first let's solve for the value of x out here. I simply expanded the bracket out here. Now I took x common from these two terms. Now I have seen this entire term, or I isolated the value of x. What I will be doing now is multiply the numerator by -1, denominator by -1. So if I multiply the denominator by -1, it would be k minus m omega square, or x is equals to k minus m omega square. Okay, and out here the numerator would be minus into minus is nothing but plus, and m omega square L naught. Okay, now the second equation, work done by external torque is equals to half m into v square, where v is equals to omega into L naught plus x. So v square would be omega into L naught plus x whole square plus half k into x square, where m omega square L naught by k minus m omega square whole square. Okay, so out here omega square can be taken outside the square root. Omega square is taken outside. Okay, so this is nothing but this value. Okay, now can I take half m omega square common from both this term? See, out here also I can take m omega square common outside, no? So it would be whole square. In the book, okay, or in the solution in the book of irodov, the answer key is given in terms of n, where m omega square by k is substituted by n. So if you substitute this entire answer, or substitute the variable m omega square by k as n, you'll get the same answer as given in the problem. Okay, so just substitute this or leave it as it is, it doesn't make a difference. The concept ends out here. In this question there is a pulley out here. Okay, and this pulley is attached to mass m1 and m2. The question is saying they'll accelerate, so mass m1 will go up, mass m2 will go down, or if mass 2 is heavier, sorry, mass 1 is heavier, this will go down, this will go up, but it depends. Okay, it depends upon the value. Asha. The question is saying when both of these masses are accelerating, find the acceleration of center of mass between these two masses. Okay, and whenever any problem of center of mass comes up, so what is center of mass? Acceleration of center of mass, or velocity of center of mass, or position of center of mass, or center of mass is nothing but mass 1 into acceleration of mass 1 plus mass 2. Achha, this is acceleration vector of mass 1 plus mass 2 into acceleration vector of mass 2 divided by m1 plus m2. Similarly, velocity of center of mass of a system is nothing but mass 1 into velocity of body 1 plus mass 2 into velocity of body 2. Okay, if there are three body system, plus mass 3 into velocity of body 3 divided by m1 plus m2. Or position of center of mass, similarly mass 1 into position of body 1 plus mass 2 into position of body 2 divided by m1 plus m2. If there are multiple bodies or more than two bodies, then what will happen? Plus mass 3 into acceleration 3 vector in the denominator plus m3. So this is nothing but summation of mass into acceleration, oh sorry, summation of mass into acceleration divided by total summation of mass, acceleration vector, summation of mass into velocity vector divided by summation of mass. Out here summation of mass into position vector divided by summation of mass. So I have to find out the acceleration of center of mass out here. Okay, center of mass of m1 and m2. So I assume that M2 is heavier than M1. Okay, you can assume the other way around also, but it doesn't make a difference in answer. Assume. So M2 will go down with acceleration. Okay, and by relation of constant motion, that means the length of the string will remain constant. So if M2 goes down with acceleration A, M1 will go up with acceleration A. Okay. Okay. Now I need to find out what are the values of this acceleration. So values of this acceleration is nothing but, if I draw the free body diagram in M1, M1G, this is nothing but M2G, out here tension T, out here tension T. So if I draw the equation 1, T minus M1G is equals to M1A, and from body 2, M2G minus T is equals to M2A, and out here T and T will get cancelled. So M2 minus M1 into G divided by M1 or M2 plus M1, which is equals to acceleration A. We have done this kind of problems repeatedly in Newton's law of motion, no? That's why I did it in quickly. Okay. Now what the question is saying is, this acceleration is the acceleration of body 2 and body 1. I need to find out the acceleration of center of mass. So out here, acceleration of center of mass is nothing but mass 1 into acceleration 1. See, out here if you consider upward to be positive, downward to be negative. Okay, acceleration of mass m1 is positive, plus m2 into acceleration of mass m2 is negative. See, it is in downward direction, but the magnitude is given by this value, divided by m1 plus m2, divided by m1 plus m2. Okay, so if you reorganize this, this would be, if I take acceleration common, it would be m1 minus m2 divided by m1 plus m2. Okay, and what is the value of a? The magnitude of value of a is nothing but this term. Okay, m2 minus m1. So if I substitute this entire term out here, I get the acceleration of center of mass. So acceleration of center of mass is nothing but a. The value of a is m2 minus m1 into g divided by m2 plus m1. This is the value of a. This is the value of a. This is the value of a. Into this entire parameter, remaining parameter, m1 minus m2 divided by m1 plus m2. So m1 minus m2 divided by m1 plus m2. Okay. Now if I take minus common out here, if I take minus common from this denominator out here, okay, I'm taking minus common from out here, it would be m2 minus m1, no? M2 minus m1, and this m2 minus m1 multiplied by this m2 minus m1 would be m2 minus m1 square. However, this m2 plus m1 and this m2 plus m1 would be m1 plus m2 square. So acceleration of center of mass would be minus of m2 minus m1 whole square into g divided by m2 plus m1 into whole square. What is the meaning of this? The meaning of this is, see, if m2 is heavier, okay, that means the center of mass, the acceleration of center of mass would be downward. This minus denotes that the acceleration of center of mass would be downward. Why? Because I have taken upward positive and downward negative. But in the question, they're only asking about the magnitude. So this much answer will suffice the question. Okay. Out here, there are two masses, m2 and m1. The relation between the masses are given as m2 is equals to m1 by 2. That means this mass is half of this mass. Okay. So if I say the mass of m2 to be m, the mass of m1 would be 2m. Okay. Now the question is saying is that this m1 travels along this path. Okay. The question is asking, find the path of m2 such that while m1 travels along this path, the center of mass of these two systems remains stationary. That means the center of mass doesn't move. So the first thing is we have to find out where is the center of mass, isn't it? So how do you find out the center of mass? Draw a straight line connecting the 2 points. So this is my straight line connecting the 2 points. Okay. Now I can either say M2 to be origin or M1 to be origin. Let's say I'm taking M2 as origin. Okay. And how do I find out the center of mass? Center of mass of M1 and M2 is nothing but M2 into position of M2 plus M1. What is M1? 2M. M2 is M and M1 is 2M into position of M1. Let the total distance be X. Okay, position of M1 is distance X from, let this total distance be X. Okay, so out here into X divided by M plus 2M, M plus 2M. So position of center of mass would be 2mx divided by 3m. M and M would get cancelled and 2 by 3x. So position of center of mass from this origin would be 2 by 3x. Okay, so that means around somewhere around here. Somewhere around here is the center of mass. Now that we got the center of mass, okay, see one thing. We got the center of mass around here. And this center of mass is not moving. Okay, this M1 follows this path, M2 will follow another path, but the center of mass will remain stationary out here. Okay, so can I say this is 2 by 3? This length is 2 by 3x and this length is 1 by 3x. What is the ratio of this length is to this length? The ratio of this length is to this length is nothing but 2 by 3 is to 1 by 3 or 2 is to 1. So 2 is to 1. So if this length, so the ratio of distance from M2 to ratio of distance from M1 from the center of mass would be in the ratio of 2 is to 1. This much is known. Okay, for the center of mass to be remain static. Okay, now what I'm doing is I'm moving the center of mass out here. Okay, this center of mass went from this position to this position. Okay, so where will this M2 move? See, I have to draw a straight line. This M2 will move towards right, no? See, I have to draw a straight line. Okay, passing through center of mass such that the ratio of this distance 1 and this would be 2. That means I always have to keep this ratio constant. This is the center of mass. Okay, so the ratio of distance from M1 to M2 would always be 1 is to 2. Then only the center of mass would remain constant. So this is the new position of M2. So it went somewhere around here. Okay, when M1 was around here, M2 was around here. Similarly, for the third position, okay, let's erase this one. So when M1 moved out here, let me draw a straight line. The ratio of this distance 1 is to 2. That means if I draw a straight line and measure 1 out here, the double of this distance measured out here would be the position of M2. So this would be, suppose I have to take 2 unit of same length from the center of mass, then the position of out here would be M2. Okay, so the next position would be out here. Okay, see what I'm doing out here. Okay, I'm drawing a straight line to the center of mass. I'm drawing a straight line to the center of mass and taking the ratio of length. Ratio of length means I'm measuring this length and I'm taking twice of this length in the straight line and twice of this length is nothing but the position of m2. Okay, so the position of m2 will follow in the ratio of 1:2. That means you have to first locate the center of mass. Okay, draw a straight line, then the position of m2 would be in the ratio of 1:2. Understood? Like this you have to draw the diagram. Okay, and after a while this position, the m2 will be somewhere around here for this position. So this is the position of m2. Okay, understood how I draw the diagram or how I drew the diagram? First I located the center of mass, then I drew a straight line from the center of mass from m1. Okay, then I'm tracing the path in ratio of 1:2. See, 1:2, straight line 1:2, straight line 1:2. Okay, then again, if the mass was out here, straight line, if this ratio is 1, twice of this length would become the position of m2. Okay, this is how we solve this problem. Okay, in this question you need to know something about inertial force. See, whenever I say or whenever you learned net force is equals to mass into acceleration in Newton's law of motion, and is to make equation T minus mg is equals to m into a. Okay, so out there this was the force out here, and this m into a was known as inertial force. Okay, inertial force. And whenever we used to change our frame of reference to non-inertial frame of reference, this portion is to come to the left hand side and become pseudo force. Okay, so make a new note of few forces that acts through the center of mass. Okay, inertial force acts through the center of mass, gravitation force acts through the center of mass, electrostatics and magnetostatics, that means any non-contact forces, acts through the center of mass. Electrostatic force, okay, then magnetic force, these all forces acts through the center of mass of the body. Okay, the vector of these forces passes through the center of masses of the body. So these forces are forces that passes through center of mass of the body. Okay, so the main thing you need to note out here, even pseudo force. Okay, if you change our frame of reference to another force, pseudo force. Okay, pseudo force, even pseudo force passes through the center of mass of the body. Okay, so whenever you are writing force is equals to mass into acceleration, this acceleration is equals to acceleration of center of mass of the body. Okay, gravitation, mg, that gravitational force or g is equals to m1 m2 by r square, that passes through the center of mass. That means any non-contact force passes through the center of mass. Even pseudo force means this inertial force goes to the left hand side and that only becomes pseudo force. Okay, even that passes through the center of mass, and by using that concept will you solve this problem out here. Okay, so out here the question is saying there is a chain out here. Okay, one end of the chain is tied to a rope, and this rope is fixed to a rod out here, and the rod rotates with angular velocity omega. Okay, rod rotates with angular velocity omega. Omega is given as 35 radians per second. So if this is rotating, that means this rope, okay, or this, not rope, this shaft, rod is rotating out here. So out here there will be tension force. Okay, now if I take the free body diagram of this chain, okay, I'm taking this chain out here, this is tension force. Okay, and the angle theta is given as 45 degree. So this angle is nothing but 45 degrees or theta. This angle is also theta. See, If this angle is theta, if I draw a straight line out here, this angle will also be theta, no? Simple geometry. Downward is mg force. Okay, so where does gravity force passes through? Gravity force passes through the center of mass. Is there any other force acting on this chain? Okay, no. So there are only two forces. One is the tension force, one is the gravity force. Now if you look the vertical component of tension force, the vertical component of tension force balances out the gravitational force. Okay, and the horizontal component of tension force acts as a centripetal force out here. Centripetal force, and this centripetal force is causing this chain to rotate. That means what is happening, the center of mass of this chain is somewhere around here. Okay, and this center of mass is rotating like this. Understood? And what is causing this center of mass of this chain to rotate? The horizontal component of this tension force. Okay, so if I draw out the equation, vertical equation, okay, t cos theta minus mg. Is there any vertical component of acceleration of this chain or of the center of mass? No, there is no vertical acceleration of the center of mass. Is equals to mass into vertical acceleration, and vertical acceleration out here is 0. So this entire component becomes 0. Okay, now the horizontal component. Horizontal component. Not exactly horizontal, the centripetal component. See, out here we do two components. One is the centripetal component and there is no tangential component, no? Okay, because this centripetal component changes the direction around this plane. So horizontal component, t sine theta, t sine theta is equals to mass into centripetal acceleration, and this centripetal acceleration is nothing but, this component is nothing but known as the inertial force. Okay, so this inertial force will pass through the center of mass. So that means this center of mass is rotating around a circle. The question is asking, find the distance of the center of mass from the axis of rotation. That means you have to find out this value of r. Okay, the value of centripetal acceleration is given by v square by r, or omega square r. Instead of doing v square by r, let's write omega square r, where r is the distance from rotation axis. So if I solve this first equation, t cos theta is equals to mg, this is our first equation. If I solve the second equation, t sine theta is equals to m omega square r. Okay, if I divide the second equation by first equation, t sine theta by t cos theta, so it would be t sine theta by t cos theta is equals to, what is the value of t sine theta? M omega square r. What is the value of t cos theta? mg. T will get cancelled, m will get cancelled. Sine theta by cos theta is nothing but tan theta. Tan theta is equals to omega square r by g. Now theta is given as 45 degree. Theta is given as 45 degree. So this would be 45. And what is the value of tan 45? Tan 45 is nothing but 1. So this entire term would be 1. Okay. Into g. If I take the g to the left hand side, or r is equals to g by omega square. Directly right now, r is equals to g by omega square, where g is equals to 9.81 and omega is equals to 35. That is given in the question. Okay, so substitute the value and get the value of r. Achha, in this question, okay, there is a cone. And this cone is rotating about this pyramid kind of thing. Okay, the axis of rotation is this one with angular velocity omega. That means the cone is rolling over this pyramid. Okay, like this. Given that center of mass of cone is around somewhere around here. Okay, center of mass of cone is somewhere around here. and this center of mass is given by 17 centimeter. So instead of using 17 centimeter, I'll use R. The angle of the cone is given as 2 alpha. So what will be half angle? The half angle would be alpha. Okay. Now the first part of the question is asking, see out here. Okay. The question is the cone is revolving around this pyramid, no? So if this point is not attached to this cone of pyramid, that means if this point is not hinged out here, okay, something is helping this cone staying out here, and that is nothing but the friction force exerted by the pyramid on the cone. Otherwise, what would happen? If the surface would be frictionless, what would happen? The cone would slip off, isn't it? So the friction force is keeping the cone on its plane, on its place. Okay. Now the question is asking, find out the value of this friction force. The first part of the question is asking, if omega is equals to 1 radians per second, find out the value of friction force exerted. So can I draw the free body diagram? Obviously I can. So let's draw the free body diagram of the cone. So this is nothing but the free body diagram of the cone. The half angle is given as alpha. Okay. If I draw a straight line out here, how much is this much angle? If this angle is alpha, can I say this angle is also alpha? Check. This angle is also alpha, isn't it? See, two parallel lines and an intercept. So this angle is equal to this angle. So what are the net forces, or what are the forces acting on this cone? See, first thing is normal force. Normal force always acts perpendicular to the surface. The second is, this is the center of mass. The second is gravitational force, which is equals to mg. The third force is friction force. Okay. Okay. Now you can either solve this question by two methods. Either taking, see, whenever there is an inclined plane or a pyramid, the best way to solve those questions are taking components along the plane and perpendicular to the plane instead of normal x and y. Okay. So if I take this axis along the plane and perpendicular to the plane, I can either solve net force is equals to m omega square r, or I can change my frame of reference to this cone. So when I change my frame of reference to this cone, what will happen? This inertial force, or m omega square r, will turn into centrifugal force in opposite direction, m omega square r. What I'm doing out here is I change my frame of reference to the cone, inside of the cone. See, now this cone, or this frame is revolving with omega. This frame is inside the cone, no? So this frame is revolving with omega, and any object this person will see will experience a centrifugal force. So the cone is experiencing a centrifugal force of m omega square r, where r is the distance of axis to the center of mass. Okay, centrifugal force, gravity force always passes through the center of mass. Understood? And center of mass means that whole cone is assumed to be a point object at this center of mass. Understood why I have taken center of mass m omega square r? Now the remaining part of the problem is nothing but resolving the force and finding out the value of the forces. So if I take along the component along the plane, or along the plane. Along the plane means I have to take all forces of all component of forces along this line. Okay. So according to this observer, what is the net acceleration along the component? 0. This observer is already inside the cone, no? So according to this observer, net acceleration is equals to 0, isn't it? So along the component, Fr, friction force. Acha, this side is should be positive. Acha, its acceleration is equals to 0 na, along the component. So it doesn't matter if you take this side positive or this side positive. Okay. So Fr, friction force, minus what is the component of mg along this line? See, out here. This line, let me draw with the red ink. This line is alpha. So mg, if this is alpha, this is 90 degree. See this triangle, little triangle out here. this will make a right angle triangle, no? So if this is alpha, this is nothing but 90 minus alpha. So mg cos 90 minus alpha or mg sin alpha. So minus mg sin alpha. Okay. What is the component of this centrifugal force along this line? See, if I shift this force or if I shift this straight line along out here, okay, the angle this straight line makes with this plane is nothing but alpha. See out here. So minus m omega square alpha minus m omega square r cos alpha. Are there any other forces along this component? No. The normal forces is perpendicular to this component. No. So component of normal force along this line would be equals to 0. So friction force minus mg sin alpha minus m omega square r cos alpha is equals to, why? Because there is no net acceleration along this line from the frame of reference of someone sitting inside the cone. Okay. So from here, can I say friction force is equals to mg sin alpha plus m omega square r cos alpha. Okay, so we found out the first value of our question. Out here substitute, m is given as, what is m? 3.2 kg. G is nothing but 9.81, or you can take it as 10 for a better approximation. Alpha is given as 10 degrees. Okay, but make sure to take alpha, sin alpha, no, it doesn't matter, sin 10 or m you know, omega is given is 1 radian per second. r is nothing but the distance of center of mass from the axis of rotation. R out here is given as 17 centimeter or 0.17 meter. Okay, into cos alpha or cos 10. So you can, if you substitute the values, you can get the values of friction force. Okay, now the second value of question or second part of the question is, at what values of omega the cone A will roll without sliding? That means what is the maximum value with which I can spin this body or which I can spin this cone so that it doesn't slide off. What will happen as soon as I begin sliding or as soon as I begin increasing the velocity? The cone will tend to fly off, no? So the question is asking what is the maximum value of omega so that the cone doesn't fly off. Understood? So to find out the maximum value of omega, we need to apply the limiting value of friction force. That means what is the maximum value of friction force in this direction the surface can tolerate? The maximum value of friction force is nothing but mu into n. Mu into n, when mu is the coefficient of friction. Now what is n? N is the normal reaction force. Okay, and in order to find out the normal reaction force, we have to take component perpendicular to the surface. So component perpendicular to the surface or perpendicular to the plane. Okay, out here component perpendicular to the plane. See, what are the components perpendicular to the plane? In, acha, are there any perpendicular acceleration? No, the perpendicular acceleration is equals to 0. So it doesn't matter you take upward positive or downward positive. Okay, n minus, what is the component of mg along the perpendicular? See, if this is mg sin alpha, along the perpendicular would be mg cos alpha, no? So minus mg cos alpha. What is the component of m omega square r? Okay, along the perpendicular, it would be, see, if this direction is cos alpha, along the perpendicular would be sin alpha. So plus m omega square r sin alpha. Why plus? Because see, I have taken this direction to be positive, so n to be positive. If n is positive, m omega square r sin alpha would also be positive, and mg, which is acting downward or in the opposite direction, is negative. Okay, is equals to mass into acceleration, where acceleration in perpendicular component is equals to 0, or n is equals to how much? Mg cos alpha minus m omega square r sin alpha. Now what I have to do is I have to substitute the value of n in this equation and find out the maximum value of omega square. Understood? So I'll just copy this equation and this equation on the next page and solve the problem. Okay. Now when I put the value of n in this equation, what do I get? Mu into mg cos alpha minus m omega square r sin alpha is equals to mg sin alpha plus m omega square r cos alpha. And what do I need to find out in part B? I need to find out the maximum value of omega because I put out the limiting value of friction force. Okay. So if I isolate, I have to isolate omega from this equation. So just multiply mu with this one, cancel out the m. So I'll do this one. Okay. And multiply mu inside the bracket. So mu mg and mu omega square r. So it would be, see, it would be mu mg minus mu m omega square r. Okay. Now what can I do? I can cancel out the m, I can take out m common and cancel them out. So let me erase this one. M, 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 m. Fair and fine. Okay. Let me write this mu properly. Okay. Minus mu. Minus. Now what else can I do? I have to isolate for omega square. So take all the terms containing omega square to the one hand side and the remaining terms to the other hand side. So this term I'm taking to the right and this term I'll take to the left. Mu g cos alpha minus g sin alpha is equals to mu omega square r sin alpha plus omega square r cos alpha plus omega square r cos alpha. Okay. Now what can I do? I can take g common from this term, or g mu cos alpha. I'm writing cos alpha as c alpha. Okay. Minus sin alpha divided by, if I take omega square common out here, omega square into r, mu sin alpha plus cos alpha. Okay. Now can I divide this, or I have to find out omega square? No. So I'll take this entire term and divide it by denominator. So it is nothing but r into mu sin alpha plus cos alpha, and erase this term. So omega square is equals to g into mu cos alpha minus sin alpha divided by r mu sin alpha plus cos alpha. But omega would be under root of, so omega square is equals to this value. Omega would be under root of this value. So just this one. Now put all the values. G is equals to 10, mu is given as how much? 0.25. In irodov they are using k, but I'll use mu. Okay, do not get confused. Cos alpha, cos 10, sin alpha, sin 10 divided by r. R is nothing but 0.17 meter. R is nothing but the center of mass, distance of center of mass from the axis. Mu again 0.25, sin alpha again sin 10 plus cos alpha again cos 10. Use calculator and find out the value of omega. Okay.